Welcome back to Deep Rob for our sixth discussion of the semester. The semester's actually flying by. If you're starting to look at the calendar, it's amazing how fast these semesters go by. Okay, so in today's discussion, the topic is going to be, today's going to be pretty brief, but I'll spend then the time for those who would like to get sort of feedback on your projects, or maybe you start to look at your papers. Also for the group, one of them's here who's doing a NERF project. I have found a way to collect some really good NERF data with my phone, so we could potentially synchronize on that, which could be interesting. But okay, so for today's discussion, what I want to do is go over a little bit more detail about the final project and these two deliverables, the first two, the review and the presentation, to try to help you as you're starting to work on those. So if you have questions along the way, feel free to stop me. Yeah, today's discussion will be probably pretty brief. So the overview of the final project, as we've been talking about, is that it's this research-oriented final project. You're now in your groups, your teams for this project, and you've been assigned a paper to review and to present on. So hopefully what you've already started doing is gaining experience reading the literature from those papers, and probably what you'll find in order to build an understanding of these papers that you've been assigned is that you also have to read the papers that they reference. And then from those papers, you'll sort of also want to read further into the papers that those papers reference. And one of the things that I think you will probably find, if you haven't already, is that doing literature reviews like this assignment often can become this kind of recursive challenge where it's like you could never, you could keep going deeper, right? You could keep reading references until the point where you might get back to like Claude Shannon on information theory, right? Like you could get back to like 100 years ago, papers from even beyond that. So one of the skills that you'll have to build as a researcher is knowing what information you need to read in depth versus what information you can skim versus what information you can sort of be vaguely aware of, but maybe not even look at the paper for. And that depends obviously on the areas where you want to build your expertise versus the areas where you're not as interested in. So hopefully you're getting some experience with that. In addition then, after those first two deliverables, the reproducing of some existing results and then proposing a new extension and documenting that will be the other three deliverables. But those are still like a few weeks away from really kind of being kind of front and center. Okay, so with that set up on what the final project is, I mentioned this in lecture yesterday, but you should have received an email from me on Thursday night. A few students I don't think should have received an email from me because I don't think that they filled out the paper survey. So if you're one of those students, you should come and contact me. I don't think that I've been contacted by those students yet. So I'll try and reach out to them if not, because they're probably not gonna hear this announcement either. So what I want to do then today is go a little bit more, talk a little bit more in depth about what to expect for the paper reviews and how to format your reviews, and also for your presentations, give some more details about how to format them. And with that, so for the paper review, I did get a couple questions about how you can find when for the paper presentations, I got this question about where you can find when they're scheduled to actually occur. And so I just want to have this slide now up on the website to make it hopefully even more clear about how the scheduling works, because I do know it's a little bit confusing. So this is like an example. Let's say that you were assigned to the Clipport paper, which is a really interesting transformer paper for robotic planning combined with perception. But let's say hypothetically that you were assigned this Clipport paper and you wanted to know when it is you're actually scheduled to present in class. So every paper does have a specific lecture where it's scheduled to be presented. So what you can do is you can go to the course website, do a Control F, like search a find operation on the page for the specific title of this paper. And what that'll do then is it'll pull you down to this section, this kind of category of papers that you've been assigned falls into. So in this case, Clipport, like I mentioned, it's a transformer paper. So we categorized it within the pre-training for robot manipulation and transformer architectures section. So you can find a link then to the actual PDF or the archive abstract of the paper here, but also right under each of these section titles, there's a link that links to the specific week and lecture on the calendar when this paper is scheduled to be presented. So if you click that link, that'll then take you directly to the calendar page, and it'll pull you down to the specific week and lecture where it's scheduled to be presented. So in this case, Clipport's a transformer paper, so the transformer architectures are being presented in week 14, lecture 26. which is April 11th. So this is for this one paper. So for your paper, then you can go through the same process and you'll find what week. If you can't tell or if you're confused about what week you're scheduled to present, let me know and I can help you find it. So based then on once you found what lecture your presentation is scheduled, then you can figure out when you should submit your review to me and your slides. So the reviews we ask 1 week in advance. So in this case, since this lecture was April 11th, go 1 week earlier in the schedule, it'll be April 4th. So you should submit your review. Your team should submit their review to me by PDF and by email by April 4th. And then in this case, 3 days before April 11th would be like the end of that Friday, so April 7th. So this is just an example to hopefully show you how you can find when your presentations are scheduled. But like I said, if you're confused about when yours is scheduled, contact me. And what I'll do to maybe also help with this, I can I'll send like a reminder email to every team, maybe like 2 weeks out from when their presentation is scheduled, just to make sure we're all on the same page and no surprises. I'll do that to try and help. Questions on finding when your scheduled presentation is that I can answer? Or other questions that I can answer on this subject? Okay, cool. So with that then, just I think 2 more slides in today's discussion material, and like I said, then I'll go around and try to give some feedback on projects or papers. So the first one I want to talk about is the review and give a little bit more context and like a little bit more information, hopefully help you start thinking about your reviews. So we have, I think, a pretty nice write-up on the Final Project website about what peer review is, what is academic peer review, what role does it play in academia, why is it important, like why is this a skill that we think is important for you to actually practice in this project. So I'll talk just a little bit about that now, which is, academic peer review is really like a core part of being a scholar. I mean, it is a fundamental part of how we conduct science in the modern times. And in particular, what it does is peer review is a way of ensuring that the publications that go out into the world from the scientific community have like a sense, like credibility along with them. So experts in the field will review the work that other scholars do before that work gets published. And so it's a way of ensuring that anything that gets published in a specific journal actually fits into that field, that the quality of the like methods that they use to study a specific approach were kind of valid, sound, that the claims were supported by the evidence that the researchers found. So that's the role of peer review. And this might sound like, I think growing up, you know, we've all probably heard this term used and it sort of seemed like something that kind of like a lofty ambition. But the reality is grad students are peer reviewers. So it's not unlikely, in fact, that probably people in this room have peer reviewed for academic journals or conferences. And it's also not unlikely that in your near future as a grad student or even as an undergraduate student maybe, you'll also be asked to review for a conference. And so I think that this project is a nice, should give you some nice exposure to some of the tools and techniques that you can use when you are going about your reviews in the future. And in particular, one of the resources I'd point out to, which is linked on the website, is there's this website called openreview.net. And so one of the really interesting trends that happened starting, I think it's actually the 10th year anniversary this year, within the machine learning community, and then extending into the robotics community and sometimes the computer vision community, there's been this trend to move towards essentially like open access publications and open review formats where the actual reviews are public. So as the name suggests, like open review, if you go to that website, you can see the comments from reviewers and from authors during the decision process for papers from conferences like ICLR, which is International Conference on Learning Representations, Coral, Conference on Robot Learning, and a few others. And these were the reviews that went into the decisions. And so they're really nice. They're dated by time, so you can see temporally like what were the reviewers' first responses, typically the authors that will then have a rebuttal period where they can respond to some of the critiques of the work and hopefully from the author's standpoint maybe change the reviewers' minds about some points. And then you can see sometimes the reviewers will respond again. The area chairs, which are responsible for actually making like a final decision on the publication decision, will then also comment. So Open Review is a great resource, I think, to actually start to get a sense of what reviewers look for in papers, how they communicate their responses to authors, how authors respond. And so that's a good resource that I think you should look at when you're thinking about your reviews. There's a few other kind of useful resources there, but at a high level, that's the motivation for this project. It's to give you, or for this deliverable, it's to give you experience thinking about what reviewers think about and how you can write reviews in a scholarly format. So that expected format, which we'll be looking for, is going to be essentially like in total, it'll probably end up being like about 5 paragraphs max. And it's a review narrative. So what you'll do is you'll first describe what was the paper about. So a summary of the paper. So you'll talk about like what problems was the paper addressing, what insight did they propose or contribute, what methods did they use to evaluate their proposed approach, what were the key results. The review summary then will be a description of essentially like what, as a reviewer, you're finding novel within the approach, what criticisms you might have of some of the techniques that they're using, and then specific points of feedback will be for any like specific like issues that you might raise or comments that you might have as a reviewer. So in total, it'll end up being, like I said, a maximum is like about 5 paragraphs. Your submissions for this should be typeset in LaTeX and then rendered as a PDF file. So we have a template on the website that we would like you to use for this LaTeX file. It's just IEEE conference style. And if you haven't used LaTeX or you're a little bit nervous about that, I can give some pointers. This is another really useful tool that as a graduate student or as an undergraduate student who's thinking about research, you essentially like need to know how to use LaTeX. So that's how papers are formatted in our field. And what questions can I answer on the review? And the motivation for the review, deadline, the expected format. Probably even less than 1 page. Once it's formatted, and then the text editor has small font. So yeah, once it's formatted in this LaTeX, it should be less than a page. Even with the title and like your teammates' names at the top, they're not very long. Yeah. And if you look at OpenReview, it's a great like place to look at. Those generally, I think, and they're in the like OpenReview itself, there's actually a paper about OpenReview when it was first proposed, and they have some interesting statistics about like the first years and how long. And I think that even there, like the average length for reviews was like 2 paragraphs, something like that. So in the review summary, let me see. So we give some like more specific details on the website, but essentially, so the paper summary is just describing essentially like what information you took away from the paper. So it's what was the paper proposing to, like what problem were they proposing to address, what techniques did they propose, what results they find, right? So you're just describing what the paper describes in a very succinct way. The review summary then is where you can actually raise like critiques of the approaches that they used. You can raise whether they were, whether they missed certain related works that you think are relevant to their work that they should have cited. So this is where you'll bring up those critiques, and then you'll sort of validate or you'll justify why you think these are critiques that the authors should consider revising in their paper, or also if you have suggestions on like additional analyses that they could perform that would strengthen their claims, or additional claims that they could potentially be making if they had just slightly different analysis, would go into this review summary. And then specific points of feedback is kind of similar to the review summary, but instead of like a summary, this is where you'll actually go like point by point. You can go like section by section through the paper if you have points for every single section and bring them up there. I'll point out, so this is what we're expecting for this class. I'll point out, and this is described on the website too, in general for venues in our field within robotics, there's also typically what's called the review scoring portion of a review. So we're not asking you to do this for this assignment, but what that will be is actually like a discrete, like there's actually a sort of categorical, discretized scoring set of options that reviewers give for every paper. So this will be like you would score what's the clarity on a range from 1 to 5, or it might be like a range from 1 to 10, depending on the venue. You would score what's the novelty of the work, how how impactful do you think this work is going to be? How confident are you in your review? How confident are you in the knowledge of your expertise in this area? So and you'll actually like numerically have to give a score assignment for those, which can be really hard to do, right? Because it's, you're trying to take your, that can be hard to do actually to like score things like that. I mean, another thing that comes up in reviewing, which we're not expecting you to, like we're not bringing up for the assignment purposes of the class, but it's worth being aware of, is when you submit a review or when you act as a peer reviewer, one of the very strict requirements is to acknowledge any potential conflicts of interest you have with the papers or with the authors that you're being asked to review. So typically, for example, if you have knowledge of who the authors are in a paper that you're reviewing and you've worked with those authors, that's a conflict of interest. If you have studied or worked at an institution that was supporting the work that you're reviewing, that's a conflict of interest. And you'd be expected as a good reviewer to acknowledge those conflicts of interest, and in some cases even not review, like decide to not review a paper if you can't do so in an impartial way. But also, it's worth pointing out that so peer review itself is an act of service to the community. So if you do serve as a reviewer, it's not uncommon to actually see people claim their service as reviewers on, for example, like their CVs or their resumes. So that's another thing to be aware of. It's actually viewed as like it's crucial to our field. Like we need peer reviewers and good peer reviewers. And a good way to look at peer reviewing is it's really an opportunity to help the authors. So whether their papers get accepted or not, like regardless of that, you can provide feedback and commentary and perspective that they might not be aware of or thinking of that can actually help shape future iterations of their papers. So even if the ultimate decision, like even if your ultimate suggestion is to accept the paper for publication, it's still useful on the author's end to get your perspective on what could have been strengthened, where were their weaknesses, was the writing clear, were there, like those kind of things are always useful on the author's end. Another good reason why this is this I think is a good deliverable in this project is that thinking like a reviewer is a really good skill to develop so that when you're deciding on projects that you want to work on, you can kind of quickly get a sense of which you think will be more fruitful or less fruitful, because ultimately, if you want your work to get published, it's gonna have to go through a reviewer. So if you can think like a reviewer and kind of ask critical questions early on in projects, you can get a much better sense of where you wanna spend your time based on where you think the projects are likely to be fruitful or not fruitful. Yeah, so that's peer review. Okay. So on the paper presentation, so this is like the second deliverable that kind of goes along with your assigned paper. So these also can be completed amongst your project teams. So these are collaborative deliverables. The expected format for the paper presentation is we'll say like a 10 to 12 minute talk that you'll give as a team up here at the front of the room to the rest of the class during our lecture time. And so like with the 10 to 12 minute talk, a good rule of thumb is to have then 10 to 12 slides with content, because generally speaking, like I said, a rule of thumb, but about 1 minute per slide is a good ballpark estimate. Slides with more technical content obviously will take longer, but that's what you should practice. But okay, so a 10 to 12 minute talk, about 10 slides in total. The topics then within this presentation that you should cover for your paper are: what problem does the paper try to address, right? So that's essentially like the introduction section of the paper. What knowledge already exists relating to this problem? So that's the related work that the paper should be describing. What insights or approaches contributed by this paper? So that's really like the core novelty that this paper has proposed. And then what methods are used and what are the key results that were found for evaluating this proposed approach? So this is where they'll describe their experimental setup, what metrics they were using for their problem, and what they found. And then finally, the last section you should cover in your presentation is what would be typically in the conclusion section. So what's left as future work. You could also have a section during your presentation of if you think that there are particular strengths or weaknesses in the approach that was used. That's also a topic that's good for starting a discussion. And so this is what should go into your paper presentation. I'll point out that presenting papers is also, just like reviewing, is a really crucial skill for any academic, because at some point, for example, once you've written your algorithmic extension and let's say submitted it to a workshop, you'll be presenting papers in an academic conference. And so that is a tremendous opportunity for yourself to actually like establish yourself as a scholar, but kind of more importantly, the reality is that in research especially, your ideas are only valuable if they can be communicated to others and others find them valuable. So if you're working in like an isolated cubicle somewhere on a campus and you come up with some amazing idea, but you can't communicate it, so you can't write it up clearly in a written format, you can't present it clearly at a conference, that idea does no good, right? So like a cure for cancer that's just sitting in a cubicle and never gets out into the world doesn't cure anyone's actual cancer. And so the same kind of, so like that's kind of the motivation for this project, for this deliverable, is just to give you some experience presenting on papers that have been published, so hopefully give you a sense of some of the challenges and some of the skills that are useful there. So also on the project website, we give some other suggestions and some useful resources linking to other external sources that have advice on how to give presentations. I would suggest looking at those. They're useful, I think. I've found them useful for my own, developing my own style of presenting. So yeah, so what questions can I answer on the paper presentation? So the question for those online was, take some of the concepts from later in the course, but even from earlier on, or later in the seminar style course, or even earlier on, I'll add, in the seminar style course, like transformers or point cloud processing. Will the papers that are presenting during those seminar style lectures be expected to actually describe the core ideas of those transformer architectures, or like what is a point cloud, for example? Or would there be some background that, like the instructor will say, like that I would give before the lecture to help kind of ground some of these concepts? So the answer is, I would say, is both. So what we'll do for discussions starting the week before week 8, so actually I think it's even starting next week, is we're gonna have these what we're calling like prologue discussions, where I'll use this time to actually give an overview of the week following's topic. So for example, like in week 7, the discussion will be on RGBD architectures and 3D perception. So I'll give an overview and help set up what these papers that we're gonna be talking about in the next week are kind of focusing on, what areas within robot perception they're focusing on. So there will be that background. But having said that, one of the really useful things to know for presenting papers, or one of the very useful kind of skills, is being able to present material not knowing maybe what your audience, to what level of detail your audience is kind of expecting. So what you typically would want to do is present the information in your paper at multiple levels of abstraction. So maybe very initially, like in those first few slides where you're setting up like what's the problem that they're trying to address, you might want to assume that from the standpoint of the students in this class, none of them have read any of the papers on point cloud processing, and you're talking about point cloud processing or transformer architectures. So I would suggest actually having some material at the start that doesn't assume people have knowledge of that. You can assume like knowledge of neural networks and convolutional neural networks, right? Like all these topics that we've been talking about, but I would try to approach it from that way. And then once you get to like later on, once they maybe have some knowledge of that, then you can talk like a little bit more details on like the approach for this paper about specifically what was the novelty in this transformer architecture. Okay, so is there a guide on how you'll be graded? There's not a guide on how you'll be graded, apart from you should address all of these points. Everything you say should be factual with regards to the paper, so don't make any claims about the paper or its results that are patently not true. And that time limit, so don't go more than like a minute below the 10-minute cutoff and don't go a minute beyond the 12-minute cutoff. We'll leave time for questions too. But beyond that, we don't have we're not looking for specific words or like specific, well, okay, be a professional and appropriate. Yeah. Yeah, so at this point, so like these two deliverables, right, like the review and the presentation, admittedly, are a little bit subjective, right? So like this notion of how you actually convey information to others, it's very subjective from the perspective of like, did you convey the information well to the audience? So I wouldn't stress though too much about the grading for these, yeah. Yeah, so the question was like, because there's multiple groups presenting at each lecture, and that is the case, could there become some coordination between the groups so that like the earlier groups in the day would take more of the background emphasis, and then the later groups can focus on like more details of the architectures and things like that. So I'll point out, in terms of the schedule, it's the same order. What we're planning to do is have the presentations be in the same order as the papers are listed. And that's also the temporal order in which those papers were published. And there is a reason there, which is that in some of the categories, maybe even most of the categories, the order in which papers are published corresponds to the, essentially like the concepts evolving. So you'll actually see ideas be reused, right? So for example, point cloud processing is an easy one. There was PointNet, and then there was PointNet++. So there's a lot of connections between the two. So it makes sense to have PointNet presented before PointNet++. In terms of, though, how much like coordination, we're not asking you to coordinate. And I would say it's probably a little bit unfair to the earlier groups to expect that the earlier groups would just cover background knowledge on maybe point cloud processing, and then the later groups could really get into like the nitty gritties on a specific architecture. So we're not asking for that, but I would say like each paper presentation should be self-contained. You shouldn't depend on the earlier group. Yes, I agree with that. So I agree with that. They should give some context, but we're not asking them to present both papers in that one presentation. So it's a judgment call. So setting up the presentation is a judgment call, I would say. And I'll also point out that one of the things that I'm actually excited about this whole final project and this deliverables, you might not realize it, but this overall structure that we're setting up is really similar to how conferences work in these areas. So basically, like and this is, I think to some extent we were planning on this, but it's kind of like fallen into place. My thinking of it has sort of evolved. Like the way conferences work, right? So before there is a conference, you have to decide what papers get accepted, which means you have to go through first a review process. So other grad students, a lot of the time, or other researchers and professors and industry experts also will serve as reviewers, but grad students, let's say, are reviewing papers for this conference. They'll get assigned reviews, so they don't get complete freedom in what papers they review, but generally they're gonna be from the areas of their interest and their expertise, which is kind of similar to how your reviews were assigned. At that point then, there's the actual conference, right? So where there's gonna be presentations given, oral presentations, and the way that those oral presentations are set up is you have these related talks happening in the same rooms. So the same way how like we have like the RGBD perception talks are gonna be on one lecture, that's kind of like how if you go to a conference, there's like a specific room where there's gonna be like RGBD perception papers all presenting in the same area. So this is kind of like a mini conference. And then the algorithmic extension is more so on like the actual research side that you would have to do to get into a conference. But anyway, so just to say that at these conferences, even though you'll have many papers from the same areas, they're all going to structure their presentations to be self-contained. So even if you see that, oh, I'm going to, you know, let's say you're going to present at ICRA this year, and you say, oh, okay, well, I'm in the point cloud processing like room, or the point cloud processing session is what they're usually called. You wouldn't sort of contact the other authors that you see are presenting before you and try to figure out what they're going to how they're going to conclude their talk to like lead nicely into yours. You wouldn't do that. You would make your talk self-contained and try to motivate it and be clear and concise in yours. And yeah. Okay. Yeah, good questions. Okay, so if there aren't any other questions, then with the remaining time, that's all the slides that I have. So in the remaining time, I'll go around and see if I can give feedback on project ideas, or if you've started going through the papers and you're confused about some of the papers or want to talk about the papers, I can do that too. But thanks for coming out to discussion, and see you next week.